Here's your guys' homework on measures of center, variation, and normal distribution. So make sure you guys take a look at that lecture because that lecture has some good, it's me explaining and giving introduction to this topic, okay? So let's look at question number 1. We gotta find the mean, median, and mode of each data set below, okay? So just like in our notes, first thing you guys want to do is probably put this in order. So we got 3, 5, 2 11s, 14, 17, and 28. Alright, so that's putting it in order. Now you have to find your mean, right? So your guys' mean is the summation of all your x values or all your data points all over the amount there are. So what's the total? How many data points are there or data values? 1, 2, 3, 4, 5, 6, 7. There's 7 total, right? So 7. Now you just add up all of them together. 3 plus 5 plus 11 plus 11 plus 14 plus 17 plus 28. And this is going to give you guys a mean. Also remember, you guys, mu, that is represented as your mean as well. So 3 plus 5 plus 11 plus 11 plus 14 plus 17 plus 28. All divided by 7. So you guys should have gotten 89 over 7, which is roughly around 12.7. So 12.7. Your median is the middle value, right? So it's this one right here. That's the center, so it's 11. And your mode, what's the most frequently number you see? It's just 11, so it's 11. 2. All right, putting these in order. 16. 24. 29, 29, 29. Ichi, ni, san. 31, 35, 49, 52, 62. Okay, so we put them in order. Now let's find our mean. So mu, which is mean, right? That's the Greek symbol for mu, which represents mean, is the summation of all your data values added together all over the total. Well, total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them total. And then we just add them all together. 16 plus 24 plus 29 plus 29 plus 29 plus 31, 35, 49, 52, 62. Add those together, and you guys get 16 plus 24 plus 24. Nope. Plus 29 plus 29 plus 29 plus 31 plus 35 plus 49 plus 52 plus 62. All of that divided by 10, which is around 35.6. Alright, so median. Let's see which one's the middle. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so these are your two middle terms, right? Those are the ones in the center. So that means to find your median, we just have to take the average of those. So 29 plus 31 divided by 2, which is 60 over 2, which is 30. So 30 is going to be your guys' median. Mode, what's the most frequent number you see? And that's 29. There's 3 of them. All right, number 3. Okay, here we go. So first, we have to find, we're going to be finding our, okay, so let's just write our equation. So first we got to find our mean, which is this, right? So we have to find our mean first. So we got 1 plus 2 plus 2 plus 4 plus 5 plus 6 plus 8. Okay? So that's what we have. all over how many of them are total. That's what n is, 7 of them. See what this is equal to. Add all of those together and we get 28, and we're going to divide that by 7, which is 4. So our mean value is 4, okay? Now we're going to get into the equations, right? So in order to find your mean absolute deviation, it is the sum all the way to n of absolute value of xi minus mu, which is your mean, all over n. Okay? So we know n is 7, right? So that means I is going to go all the way from 1 to 7. So what is our first data value? Because that's what, if you plug in 1 into the I, that's going to be x1, right? So what is your first data value? It's 1, right? So absolute value of 1 minus, what's our mean? We just found it to be 4. And it's all over n, right? So this is going to be all over n at some point. Okay, so that's our first one. What's our second data value? Because that's going to be x2, right? Well, our second value is this one, right? So 2 minus your mean absolute value. Okay, what's our third? It's 2. So our third data value is 2. So 2 minus your mean. Fourth data value, 4. 4 minus your mean. Fifth data value, 5. 5 minus the mean. Sixth data value, 6. 6 minus the mean. And your seventh data value, 8, which is 8 minus your mean. All over, how many total? There's 7 numbers in total. So now we're going to simplify this. 1 minus 4, absolute value of that, you guys. Well, 1 minus 4 is negative 3. Absolute value of that is just 3. 2 minus 4, absolute value of that is just 2. Right here, 2 minus 4, negative 2. Absolute value of that, 2. 4 minus 4, 0. 5 minus 4, 1. 6 minus 4, 2. 8 minus 4, 4. And now we can just add those all up. So 3 plus 2 plus 2 plus 0 plus 1 plus 2 plus 4. 14 all over 7, which is equal to 2. So our mean absolute deviation is 2. All right. All right, moving on. Let's get our variance. And remember, variance is represented as sigma squared, right? So sigma squared is equal to, okay, so it's the summation of xi minus mu, which is your mean, minus your mean, squared all over 2. Okay, so again, we have to just keep on substituting your i's into this equation and then all the way up to n, which is your 7. And I don't know why I wrote 2 right here, because it should be n. Alright, so if you substitute I1 into I, that's x1, right? So what is our first data point? It's 1. So 1 minus your mean 4 to the second. We're all going to put this all over this again, and it's all going to be over 7, right? Because there's 7 total. Okay, what is your second data value? It's 2. So 2 minus your mean squared. What's your third data value? 2 minus your mean squared. Fourth data value, 4 minus your mean squared. Fifth, 5 minus your mean squared. Your sixth data value, 6 minus your mean squared. Oh, that's not minus my mean. plus your 7th data value, 8 minus your mean squared. All right, so we're going to simplify this. So 1 minus 4, that's negative 3, right? So negative 3 to the second is just going to be 9. 2 minus 4, that's negative 2. Negative 2 to the second power, that's going to be 4. 2 minus 4, negative 2, raised to the second power, 4. 4 minus 4, 0, 0 squared, 0. 5 minus 4, 1, 1 to the second, 1. 6 minus 4, 2, 2 to the second, 4. And 8 minus 4, 4, 4 to the second, 16. So let's add all of these together, and you guys are going to get 9 plus 4 plus 4 plus 0 plus 1 plus 4 plus 16. So you're going to get 38 all divided by 7, which is roughly going to be 5.4. It's going to be 5.4. There's your guys' variance. And now all we have to do is get your standard deviation, you guys, which is just sigma. Now, we know from the previous problem the variance, which is sigma squared, is equal to 5.4. Or it was roughly 5.4. So for that, all you have to do, you guys, is just square root both sides. And we're going to get square root of that, which is going to give us sigma is 2.3. All right? And that's how you guys do those types of problems. So we'll go at it again. Okay, so we have to put this in order first. So 9, cross off. What's the next number? 13, 14, 20, another 20, 27, 31, 32, 33, and 41. So that's what it is in order. Now we gotta find our stuff. So I am gonna write all of this again. I'm actually gonna move this. All right. I don't like the position of where I put that. Okay, I know what I'm gonna do. Okay, I tried to cheat the system, you guys, but obviously that did not work. I know what. All right, there we go. Okay, so I'm gonna shrink it down even more. So there's our numbers. Now we can find our mean, right? So your mean is gonna equal to the sum of all of them. So we are gonna have 9 plus 13 plus 14 plus 20 plus 20 plus 27 plus 31 plus 32 plus 33 plus 41 all over the total amount of numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. All right, so put this in your guys' calculator. You got 9 plus 13 plus 14 plus 20 plus 20 plus 27 plus 31 plus 32 plus 33 plus 41. 240, all divided by 10, which is 24. So your mean's 24, and now we are going to be doing these now. Okay, so we are going to do the first number, which is 9, right? So 9 minus your mean plus absolute value of what's your second number? 13. So 13 minus your mean. And it just keeps on going, right? Your third number minus your mean. Your fourth number minus the mean. Your fifth number minus the mean. Your sixth number minus the mean. Your seventh number minus your mean. Your eighth number minus your mean. Ninth number minus your mean. And finally, your 10th number minus the mean. All over 10. So now let's simplify this. So 9 minus 24 is negative 15. Absolute value negative 15. 15. 13 minus 24, negative 11. So positive 11. So I'm just going to keep on going, you guys. So remember, absolute value gives you the positive value, right? So you guys have all those, and then you add up all of those numbers, and you get 15 plus 11 plus 10 plus 4 plus 4 plus 3 plus 7 plus 8 plus 9 plus 17. You get 88 all over 10, which simplifies to 8.8. So this is your mean absolute deviation, okay? And now we got this. So as you guys can see, the more you guys do this, the more like you start getting used to it, right? The pattern. So summation. So what's the first one? It's 9 minus your mean, which is 24, squared, plus second term, second data value, 13, minus your mean, squared, plus 14 minus your mean, squared. Your fourth term, which is 20, minus your mean, squared. And so on, you guys, right? It's just a continuous pattern that you guys keep on subtracting by the mean by. So 27, 31 minus 24 squared plus 32 minus 24 squared. (31). Next one, 32 minus 24 squared plus 33 minus 24 squared plus 41 minus 24 squared. Okay, all of this all over the total, right? Which is 10. All right, time to simplify this, right? So 9 minus 24 is 15, negative 15. Negative 15 squared, that's going to give you 225. 13 minus 24 squared is negative 11 squared, which is 121. 14 minus 24, which is 10. Negative 10. Negative 10 squared, 100. 20 minus 24, negative 4 squared, 16. And I'm just going to keep on going. And you guys are going to get this. 17 squared, 289. Alright, so we have that finally. So now let's just combine all those. 225 plus 121 plus 100 plus 16 plus 16 plus 9 plus 49 plus 64 plus 81 plus 289. All 970 all divided by 10, which is equal to 97. So we got a variance of 97. Now remember, sigma is standard deviation sigma, so sigma squared, you guys, from the previous problem equals 97. Take the square root of both sides. So your standard deviation, which is sigma, it's going to equal to 9.8, which is your guys' standard deviation. Okay, we're not doing 5 and 6, okay? We're not going to be doing 5 and 6. That is good enough. Alright, moving on. Okay, so now we have this, you guys, okay? So, using your guys' empirical rule, right? This was also from your guys' notes. There's this center, right? This first standard deviation. Here's the second standard deviation. And here's the third standard deviation away from the mean. So here's your guys' mean, and you put them in this middle. And then, so if that's the mean, you guys, then everything apart from that, every block is a standard deviation away. So it says our standard deviation is 3, right? So 3 away from here is 79, 3 away from there is 82, and 3 away from there is 85. The other way, 73, 70, and 67. 3 away, right? Because it says standard deviation is 3. So once you guys set that up, now let's put in our percentages, right? This is 34.1%. 34.1%. What else do we got? We got 13.6%. 3 standard deviations away, so we have to include 2.2%. And lastly, 0.1% for the ends. Alright, so once you guys set that up, your empirical rule, now we can just find our answers. So it says what percent of the scores are between 67 and 85? So what percent of the scores, right, is from 67 all the way to 85? Well, basically, you just add those percentages up, or you can just subtract 100% from these two, right? But I will do the adding part. So 2.2 plus 13.6 plus 34.1 plus 34.1 plus 13.6 plus 2.2. And this is the percentage of what's between 67 and 85, which is 99.8%. So there's that. Part B, what's the probability that a score is no more than 79? So that means, you guys, what's the chance of it being no more than this value? So that means what's the percentage of all of these combined? Essentially, that's what it means to be that a score is no more than 79. Well, 34.1 plus 34.1 plus 13.6 plus 2.2 plus 0.1. Add those all together, and you guys should get, I will be adding it as well, 84.1%. Okay, part C, how many scores fell between one standard deviation of the mean? Well, one standard deviation from the mean, you guys. Okay, so so it's asking how many scores, right? Well, there's a set of 125 goal scores, right? So that means when you look between one standard deviation away, this is one standard deviation away, and this is one standard deviation away. So they're talking about between that. How much percentage is one standard deviation away? And it's 34.1 plus 34.1, which is 68.2%. But they're not asking for the percentage, right? They're asking for how many scores. So you got to multiply 68.2% times the golf scores, which is 125. So this is equal to 0.682 times 125, which is equal to a score of 85.25. All right, so there's that one. Now we're going to do question 8. All right, so I'm going to set this up like how I did up here. All right, but the only difference is now we have a different set of scores and what stuff, right? So it says group of cell phones normally distributed with a mean of 5 hours. So 5 hours, we're going to make that into minutes. That's 300 minutes. That's 300 minutes. And now we are going to do standard deviations away. So 315, that's one away this way. 285, that's one away this way. 270, 255, 330, and 345. All right, now we can start. What percent of phones have a battery life of at least 4 hours and 45 minutes? So 4 hours and 45 minutes, you guys, is this mark. $285 you guys, that's 4 hours and 45 minutes. So, knowing that, what percent of the phones have a battery life of at least 4 hours and 45 minutes? Well, at least, right? So it's talking about this right here. Right? So all of those percentage added together, you guys, that's going to give you 84.1%. What percent of the phones have a battery life between 4.5 hours and 5.25? So this is the 5-hour mark, right? So the 5.25 mark is right here, and the 4.5-hour mark is right here. So that percentage, you guys, added together, that's going to give you 81.8%. You add those all together. Okay. And then lastly, what percent of the phones have a battery life less than 5 hours or greater than 5.5? So less than 5 hours. So this is the 5-hour mark, right? Which means you have to add up all these percentages. And greater than 5.5 hours, which is 5.5 hours, that's this mark, you guys, and it's adding all of these together. So adding those circle percentages together, and you guys are gonna get 52.3%. 52.3%. Okay, now we go ahead and do 9 and 10. So 9 and 10 is just pretty much you not having the graph above, okay? But it's pretty much the same type of thing. So the number of hours that the employees at the grocery store worked at least is normally distributed with a mean of 24. So a mean value of 24 and a standard deviation of 6. If there are 60 total employees, approximately how many worked at least 30 hours last week? So probably it works best if you guys are given a visual. So how many workers worked at least 60 hours last week? So basically, right, I'm going to draw it. So if this is the 24 mark, right, and this is 24 hours, so this mark would be 30, because that's one standard deviation away this way. This is 18, that's one standard deviation away this way. So it says how many it worked at least 8 hours, right? Or sorry, at least 30 hours last week. So here's that mark, right? This is the mark that you'll be dealing with. And since it says at least, it's talking about all of this percentage over here, right? It's talking about that percentage. So let me give you guys a visual because I know a lot of you guys are visual learners. So 0 0.1, 2.2, 13.6, 34.1, 34.1, 13.6, 2.2, and 0.1. So this is pretty much like the chart above. You know this is 24, right? And it says a standard deviation of at least 6. So there's this 30-hour mark, right? Because it's 6 away from 24. And you know that what if there are 60 total employees, approximately how many worked at least 30 hours, which is that mark, right? So it's asking what is this percentage right here? Well, add those all up, and you guys should have gotten 15.9%, but it's asking how many worked, right? How many of those 60% workers worked? So that means you have to multiply it by 60. 0.159 times 60, which is equal to 9.54 people, which is really just 9 people. Okay, I'm going to use this exact same chart for the one on the bottom. Alright, the grade point average of the GPA of a student is normally distributed with a mean of, okay, so the mean is 3.1. Standard deviation is 0.3. So that means you guys could go out from 0.3 from this mean, right? 3.4, 3.7, 2.8, 2.5, and that looks good enough. Okay, so there's 1,800 students enrolled. Approximately how many have a GPA? So how many of them have a GPA from this mark to this mark? And it's that percentage right there. So we have to add this percentage together. So 13.6 plus 34.1 plus 34.1 plus 13.6, that's 95.4%. So 95.4%, but you gotta multiply it by 1,800 to get how many of those students' GPAs are between those two. So 0.954 times 1,800 is equal to 1,717.2 students, which is just 1,117 students. Okay, so that's how you guys do those problems, and good luck, okay?